just to quickly introduce myself a little bit further, I basically describe myself as a hybrid. I did a double degree in computer science as well as structural engineering. And the other way I've been describing myself recently is an aggressive implementer of IFC, and this is part of the reason that I come to talk in front of you today. And that's basically been helping BuildingSMART with testing new proposals and features of IFC and using a lot of industry experience that I have to help facilitate in testing and reviewing those sorts of concepts and how they're represented. The first question really, I guess, is what is BIM? And I'm certainly not going to answer that here. These images come up in all sorts of presentations, including some that you'll see later today. But the idea of BIM, I mean, BIM isn't new. We've been exchanging information about building for centuries, but more traditionally in the form of paper documentation, so technical drawings, schedules, specifications, and reports, and these types of things. And what is new about BIM, as we sort of commonly referring to it now, is this digital exchange, which primarily means it should be machine readable or readable by other processes and tools that are being involved in using this data. And so at the moment, and I think this is only going to get more and more complex, we're going to introduce new tools, new software, new processes around these requirements and stages of design, documentation, delivery, operation, maintenance, demolition. And what becomes really fundamental then is the mechanism that we use to exchange the information between these processes. And this is where IFC, or the industry foundation classes, has a really important role and ability and capability to facilitate and enable that. So I don't know how many here have, normally I do question, who here has used IFC before on a project? A few. And who's been happy using IFC before on a project? Not as many. Okay, good. And that's a pretty typical response. And I mean, again, BuildingSMART could be using lean processes, I'm sure, to look for this improvement and making sure we do this better and really capture the potential of and the requirements and necessities that we need for this. So industry foundation classes are actually over 20, I think they're 21 years old, if not slightly older now. It was born out of an alliance. It was actually started as the Autodesk foundation classes. And it was this ability to take model data or information requirements and use them in another application or process that wasn't there. If we're looking, IFC4 was released about 2013, and there's a target release date of IFC5 in 2020, where the emphasis is on changing from buildings perspective to infrastructure perspective. And I'm going to touch a little bit about what's coming in terms of infrastructure, but just note that traditionally to date, the industry foundation classes have been developed and applicable primarily to buildings. So I guess a question then, well, if we already have other data exchange formats like Land XML and CityGML, why do we need IFC in infrastructure? And I think the fundamental thing is IFC is multidisciplinary, and that's really what it's going to bring to the table. It's actually capable of project and data representation, including systems and networks, work plans, cost plans, project breakdown, work breakdown, analysis, including structural analysis or environmental analysis, and operations maintenance through the entire life cycle of the project. So it's a very rich data model. Typically to date, it's only been used for coordination, and the reason why a lot of hands went down having used IFC to having been happy with using IFC is that the demand on industry foundation classes is actually more than coordination. And given that most of the software implementations to date have been very focused on coordination model exchanges, when people start to try and use it for design transfer or actually using the information intelligently downstream, they've had a lot less success in doing so. And I think fundamentally that many of the concepts that we've used in building do apply to infrastructure, albeit in a slightly different way. And there's many lessons already learnt from developing the IFC data model for buildings that we can take lessons learnt and apply to infrastructure, and we don't have to start again from scratch. So I think it's a very big benefit that can also bring to this. Anyone that's actually used industry foundation classes before, you've probably never been game or brave enough to actually look at the .ifc file that's created and open it in Notepad, but you can. This is one of the benefits that industry foundation classes bring. I'm not saying this is human readable. As I said, the emphasis on industry foundation classes is actually machine readable exchange. It actually is born out of STEP, so it's actually it's technology that's from 20 years ago where we're looking at saving data on a floppy disk. But if you can, I know it's not particularly clear, I can make the slides available, but effectively each line introduces a concept, and it has attributes, and then it has relationships to other lines and objects within that data model schema. So this is basically a definition of alignment, and it's describing what are the segments of the transition curves, where is the linear, the arc, or the clothoid curve that's defining that transition, and it's using, as I said, specific attributes or relationships to build up that intelligent data model as part of it. That step, which is the common format, which is actually used to exchange the IFC, but the actual emphasis is on the data model, not on how you serialize or deserialize it to a text file. And another official format of IFC is IFC which is a little bit more modern. It's a little bit more human readable because we actually get every attribute to be tagged, so we can actually start to identify it. And so it does make it easier to review and interrogate what contents of this data as a human being, which I actually do think is important. What is important with this is, as I said, not how the format that you use, but the fact that you can actually interchange. So it's the data model that's common between these different formats, not the actual way that it's written to a text file. Personally, I've been involved with a few web server projects, particularly around object libraries, and given a lot of JavaScript development, JSON is an even more modern way of serializing and deserializing the data to text, and we've been doing some exploration with this and use of this. The back-end developers were much more comfortable writing a JSON string than looking at a step file. This isn't official yet, although again, there's some consideration about this as part of this workflow. So let's start to look at actually what's coming in IFC5 and linear infrastructure. And there's a project which is actually being led in Australia here by Jim Plume in Sydney about common schema. So the idea is that IFC file is going to introduce concepts that are applicable to rail, to road, to bridge, to tunnels, to ports and harbours, and to other infrastructure domains that are going to use this as an exchange format. And the emphasis really for IFC5, I think, given that we're only about a year or two a bit away from a release date of that, is starting to enable the common schema aspects of this, but we'll also look at what we can do in terms of classification in using IFC 2x3 even right now without waiting for IFC5 to be introduced and implemented so that we can use it. But some of the concepts that are particular being introduced to IFC that we haven't had a need for to date in buildings, so alignments I mentioned, so how do we describe the transitions between segments of an alignment? Cant is being considered at the moment, so there's a proposal about how we consider cant on an alignment. Linear positioning, triangulated network representations of site. Classification I'm going to touch on a bit further in a second, because actually that's where I think the important work is in IFC5, but where most people think you can't use IFC today for infrastructure. What they really mean is that you can't actually classify or identify if something is a platform or a train station or a network drainage or system as part of it. There'll be some more shape representations introduced, so things like voxel diagrams for a port is one thing that's being considered. And then particularly in geotechnics, I've just returned from the BuildingSMART Summer in Tokyo, the international summit, and learning a little bit more about uncertainty and risk and the difficulty in actually describing geotechnical data within a standardized format. I'm not going to talk too much about COBie. I know there's a presentation by Nathan this afternoon who's going to dig into the nuts and bolts of COBie. And most people think of COBie as a spreadsheet, but what it really is a set of information requirements, and it's an agreed set of properties that they wish to use to convey an exchange handover as part of this. So COBie is really, as I said, just a set of property templates that might describe the units and what elements they're actually applicable to. And where I've been recently involved, particularly in an infrastructure sense, is helping support a little bit Transport for New South Wales with their digital engineering framework. And they've sort of looked at COBie, which is again born out of buildings, and not directly, I think it has some shortcomings that don't make it difficult to use on an infrastructure project. And what Transport for New South Wales have done is identified the concepts out of COBie and started identifying, or as part of their release, making their own project delivery spreadsheet, which is a structured spreadsheet, which actually we can then use to push and pull with IFC data coming from other sources. So I did a bit of a mock-up prototype for them, and other projects are sort of being pushed through it at the moment, but how do we actually, this is Revit, which is again born out of the building software. You can start to see my own experience in building or comfort in buildings, but The idea being that we can take conceptual models and actually manage the information requirements in a standard way that Transport for New South Wales will require. So in this particular case, we can actually input data from other sources, including even manually in a spreadsheet, taking an IFC, which is an export from Revit, appending and morphing that data from the structure of the spreadsheet, and then producing one single exchange file as a result of that. And then I'm going to, just to quickly demonstrate some perhaps infrastructure concepts about how they might be represented in IFC. And again, if you can't read this, don't read today, I will make this available. But the first is that you can actually have a spatial or project breakdown of a project. I've been doing some work, which I think I might have a slide in a minute, in how do you describe a whole road network or a rail network, and then break that down into sections and junctions and stations and other sectors and things like that you might exist in that. So IFC has this model hierarchy where you can break down from a site or a complex to a facility down to the products, but then also have grouping. So IFC also has things like systems, which allows you to group by a common attribute the products or the complexes, etc. And you can use identification. In this, again, to use IFC for an infrastructure sense, we have been heavily, and Transport for New South Wales did a lot of research about how could they have an agreed consensus on classification of the products and complexes and systems within their information requirements. They compared a whole bunch of classification systems, and I'm not here to sell you Uniclass today, Mike or someone might do that, but they came to the conclusion that Uniclass actually was pretty well suited to their needs for project delivery, and that way then we can have fairly generic classification within the IFC. Something can be a building element proxy or just a system, and then we can use Uniclass as a relationship to infer, is that a platform, or is that a station, or is it a road, motorway, or these types of concepts that we might use in a standard way across the consultants and stakeholders. And then the third way, so here, actually this slide is here starting, so you can actually interrogate the IFC model through the various ways. So here I have a grouping of a mock-up I did of the light rail for Sydney, where we can actually start to isolate. Will just give me all the light rail stations which exist within the network. There's also then ways of pulling out communication or external furniture or other systems that might exist in that. And then, I mentioned before, so there's been other prototypes where we've been trying to push the data models through the IFC framework. The earlier we can test the concepts of IFC as they apply to infrastructure, the better, and the earlier we can then influence the design schema. I don't think we're going to get a worldwide consensus about how we break down a network, but what we need to make sure we can do is that the IFC data model doesn't prohibit a client or a stakeholder from arranging the hierarchy in the way that they require. And again, so we went down from the entire country of Sweden, being broke down into admin regions or states, and then the individual motorways or arterial roads, etc., down to the corridors, and then down to the different lanes and junctions and the different elements which would actually comprise a road network. So IFC facilitates a very strong hierarchy, or it allows you to use it to define your own hierarchy as part of that sort of asset description. Drainage, again, this was a topic not of my expertise that I just presented on, but again, just testing systems and connectivity, and even using layer classifications from CAD backgrounds in a design perspective. And just to touch on a couple of points then. So I still think IFC4 was released in 2013, unfortunately for reasons in terms of certification and getting agreement around actually what should be in the subsets that the implementations use. IFC 2x3 is still dominant, which was released 2007, so that's now 11 years old. But the work I've been doing shows that a lot of the IFC 2x3 is capable. So if you couple IFC 2x3 up with a classification such as Uniclass, it could be a bespoke or client-specific classification, that's fine. But then we actually can do a lot with infrastructure today. The other thing, when you're actually doing these exchanges, I certainly recommend don't just ask for an IFC as a deliverable. Do require the proprietary and the actual software implementation models as well. Even if it's just for when the IFC exporter improves, that we can actually regenerate the IFC files and improve the IFC files in the future. And the other thing, if you are frustrated with IFC, just don't sit on bugs and frustrations. Please demand fixes. So all these software developers are businesses, and if you're not asking for them to fix it, they're not just going to do it out of the goodness of their heart. The other thing as well, I guess, I've been doing a lot of work. I think we're going to see a lot of big IFC files generated from infrastructure. That shouldn't be the case. You can use smart shape representations and things like that. So if you're generating IFC files from a technical perspective and their magnitude's bigger than the file that you save for your proprietary file system, seek clarification or advice from someone like me or BuildingSMART that can help allow you to identify what the improvements are that you should mandate on your vendors. So look, that's basically what I wanted to present today in a short duration. Hopefully it gives you some insights into IFC as an information requirement and data model. If there's any questions, I think we've still got a couple of minutes to take any questions.
Thank you, John.